Imagine stepping inside the actual architecture of an enterprise-level operating system. You aren't just looking at the user interface anymore. You are staring right at the raw database schemas, the
Hmm.
financial ledgers, and those automated daemons just running silently in the background.
Right.
To master a system like that, you really have to shift your mindset. I mean, you can't just memorize what the software does. You have to prove you understand the exact computer science and the structural logic dictating how and why it functions under pressure.
Yeah, exactly.
And that is the barrier to entry you are facing today. As we take a deep dive into the Broadcom 250-609 certification exam, we will be taking a highly deliberate, very measured pace today. We're going to systematically examine 10 specific scenarios from this exam, strictly in sequential order.
Right. Because it requires a rigorous methodology.
Exactly. We will read the exact prompt, identify the definitive solution, and then completely deconstruct the technical mechanisms that make that answer correct.
Yeah. For a certification like the Broadcom 250-609 exam, you have to remember that the distractors in the multiple choice questions are often plausible configurations. So to consistently identify the correct architectural choice, you have to really understand the foundational guardrails the system enforces to maintain enterprise scale.
Right, to keep the system stable. So let's start by examining those foundational guardrails at the object level. Question 1. When designing a custom experience using blueprints, what is the underlying principle controlling how many instances of a subordinate object a user can generate?
The correct answer is A. A blueprint defines the structure and behavior of a custom experience, including the relationship between parent and subordinate objects. Its configuration can specify how many subordinate object instances users are permitted to create for an associated module.
Okay, so let's dig into the computer science of that. Why does the system actually care if a user wants to generate 10 subordinate objects, or, say, 10,000?
Well, it comes down to database instantiation and memory allocation. When you allow a user to create a subordinate object, you are literally giving them permission to write new rows into a relational database table.
Right.
And that consumes index space and processing overhead. So if you do not establish hard constraints within the blueprint configuration up front, a rogue script or even just a simple user error could theoretically trigger an infinite loop.
Wow.
Yeah, just spawning millions of child records over and over.
Which would effectively launch like an internal denial of service attack on your own architecture.
Exactly. You would lock the tables and severely degrade the system-wide performance for everyone. So setting that limit upfront in the blueprint, it isn't just about keeping the user interface clean, it is a structural safeguard.
It's like building a house where the blueprint literally dictates how many guest rooms you are legally allowed to build, just to prevent the foundation from collapsing.
Right, it ensures predictable database growth, it prevents systemic chaos.
That makes total sense. We constrain the structure to protect the resources. But, those resources actually have to execute tasks, which brings us to how the system manages processing power. Question 2. In the context of configuring automated workflows, what distinguishes a background job action from a manual action step?
The correct answer is B. A background job action runs predefined application logic automatically, without requiring a user to perform each step manually. A manual action, by contrast, depends on a user initiating or completing the required operation.
So to clarify the mechanism here, is a background job functioning essentially like a cron job on a Linux server?
That is a highly accurate comparison, yeah. Background jobs act as invisible daemon processes.
Yeah.
They operate entirely independent of the active user session.
Okay.
The system can queue these automated workflows to execute their predefined logic asynchronously, and it's often scheduling them during off-peak hours just to optimize server compute cycles.
I see. Whereas a manual action that acts more like a hard system interrupt.
Precisely. A manual action creates a synchronous bottleneck by design. The workflow thread reaches that specific node, and it simply suspends execution.
It just stops.
Right. It enters a holding state. It's waiting for a specific Boolean trigger, like, say, a user clicking approve, before it will pass the baton to the next step.
Okay, so understanding how to balance those invisible asynchronous daemons with intentional synchronous interrupts, that's really a core competency tested on the Broadcom 250-609 exam.
Absolutely.
So we have these background workflows executing, and we have human users interacting with the system. But human labor at the enterprise level has a distinct financial weight, right? Especially when those humans cross departmental lines. Let's look at how the architecture resolves that. Question 3. How does the system resolve conflicts when a resource is assigned to an organizational breakdown structure unit that differs from the primary project financial entity?
The correct answer is C. When the resource and project are associated with different financial entities, the application uses the entity connected to the resource when determining applicable costs and rates. This supports more accurate resource-based financial calculations.
Wait, I want to challenge the practicality of this. Let's say a marketing project has a very strict, fixed budget.
Okay.
If they borrow an expensive database architect from the IT department, and the system automatically applies that architect's higher IT rate to the marketing project, doesn't that immediately blow up marketing's financial forecasting?
I mean, it absolutely might blow up their forecast.
Right.
But the enterprise architecture prioritizes global financial truth over departmental convenience. If the system altered the architect's cost rate just because they were temporarily logging hours on a marketing initiative, the general ledger would lose its integrity entirely.
Oh, wow. So you can't just hide the cost.
Exactly. The system hard codes the financial entity to the specific resource so that cost calculations remain universally accurate across the entire enterprise, regardless of where that resource is actually deployed.
So the financial burden follows the specific employee preserving the ledger. That establishes the cost, but there is still the matter of how the system actually moves that cost around the organization. Question 4. During the processing of financial transactions, what underlying condition must be met before a cost recovery rule can successfully distribute expenses across different departments?
The correct answer is cost recovery rules operate on transactions that have already completed financial processing and have been posted as work in progress. Until the transactions reach WIP status, the system cannot distribute the expenses according to the recovery rule.
So what is fundamentally changing in the database when a transaction shifts to work in progress or WIP status? Why is that the mandatory threshold?
It's really about locking the record to prevent race conditions. When a transaction is initially logged, it is in a mutable state.
Meaning it can be changed.
Right. It can be edited, rejected, or just deleted entirely. So if a cost recovery rule tried to distribute an expense while the primary transaction was still mutable, you could end up with a severe accounting error, like distributing a cost that gets subsequently deleted.
Oh man, that would be a nightmare. You're distributing an expense that is basically floating in the ether.
Exactly. It has to be solidified first.
So hitting WIP status essentially turns that record into read-only data for the secondary systems.
That is exactly the mechanism, yeah. Posting to WIP finalizes the initial financial processing. It commits the transaction to the database as a verified truth. And only when that state change is confirmed can secondary automation, like a cost recovery rule, safely query that data and distribute the expenses without any risk of duplicating or corrupting the financial ledger.
We are definitely seeing a major theme of locking down historical data here. But what happens to that locked data when the underlying company's structure drastically changes, say, a reorg? Question 5. When synchronizing structural changes into an existing workforce plan, how does the application handle historical data assigned to deactivated departments?
The correct answer is A. Deactivating a department prevents it from being used for future planning assignments, but it does not remove its historical information. The application retains previous planning and financial data to preserve reporting accuracy and audit history.
Wait a second. Preserving potentially decades of historical data for departments that literally no longer exist, that sounds like a massive recipe for database bloat. Doesn't retaining all of that deactivated data eventually slow down the system's daily query performance?
Well, it would if the system handled it poorly.
Okay.
But enterprise architectures utilize a concept known as soft deletion or logical deletion. When a department is deactivated, the system does not execute a destructive drop command on those tables.
It doesn't actually delete it.
Right. Instead, it flips a Boolean flag on the department record, changing a field like IActive from true to false.
So the daily operational queries are automatically filtered to just ignore anything where the active flag is false.
Exactly. The daily UI remains clean and fast because it isn't rendering the deactivated departments, but the raw data remains completely untouched on the server disk. This is a non-negotiable compliance requirement.
Because of audits.
Yes. If an auditor needs to run a financial reconciliation from 3 years ago, the system must be able to recreate the exact organizational reality of that specific time period.
So it isolates the past without destroying it. That makes sense.
Let's pivot from preserving the past to introducing the future. How does the architecture handle deploying brand new capabilities? Question 6. What is the primary architectural implication of enabling an experimental capability through the feature management interface in a production environment? The correct answer is C. Enabling a capability through feature management makes that functionality available within the applicable environment. It does not normally rewrite or delete historical records, although experimental features should still be evaluated carefully before production use.
The warning in that text is super interesting to me. If it doesn't destructively rewrite the database schema, what is the actual risk of enabling an experimental capability globally in a live environment? I mean, it says right there the records are safe.
Yeah, the records are safe, but the risk lies in the application layer and the user experience. Feature management utilizes feature toggles. When you flip that toggle in production, the application logic instantly begins routing users to the new experimental code paths.
Right.
And while the underlying historical data is safe, the new interface might contain unhandled exceptions, or it might interact poorly with heavily customized client environments.
So you could theoretically crash the UI for thousands of active users simultaneously, even if the database itself remains completely intact.
Yes, absolutely. You might introduce a bug that prevents users from executing core business processes. That is exactly why the Broadcom 250-609 exam emphasizes this distinction so heavily. Feature toggling is an incredibly powerful deployment strategy because it avoids those destructive schema changes, but treating a production environment like a sandbox, that is a massive operational risk.
Yeah, that's terrifying. It is truly fascinating to see a multi-million-dollar architecture carefully route its logic through feature flags and complex financial ledgers, only to be entirely bottlenecked by the people using it.
It's always the people.
Which brings us to question 7. When analyzing the discrepancy between planned resource allocation and actual recorded hours, what is the root cause if the total effort remains significantly below the approved threshold?
The correct answer is D. Actual effort is normally derived from submitted and processed timesheet entries. When assigned personnel have not submitted their completed work logs, the system records fewer actual hours, causing actual effort to remain below the planned or approved amount.
I really appreciate the irony here. You can engineer the most sophisticated asynchronous workforce plan in the world, and it all fundamentally breaks down because an engineer just ignored their calendar reminder to submit their timesheet on a Friday afternoon.
It perfectly illustrates the garbage in, garbage out principle. The entire architecture is entirely dependent on the primary key of actual hours.
Right.
If the timesheet isn't submitted, that data field remains null. And when that field is null, every single downstream aggregation fails. Your earned value management metrics skew wildly, your cost tracking shows an artificial surplus, and your resource allocation reports suggest you have excess capacity when you actually don't.
The human element really is the ultimate single point of failure.
Without a doubt.
So, assuming we can get the humans to actually input their data, we also have to ensure they're working on the right things in the first place. Question 8. During strategic organizational planning sessions, how does the roadmap functionality ensure that operational investments align strictly with high-level business objectives?
The correct answer is B. Roadmaps support strategic alignment by connecting planned investments, projects, or initiatives directly to defined business goals. These relationships allow decision makers to evaluate whether proposed work contributes to the organization's strategic objectives.
From a database perspective, how is a roadmap establishing this? I mean, is it just a visualization tool for executives like a nice chart, or is there a real structural constraint happening under the hood?
Well, it is absolutely a structural constraint. A roadmap in this context forces the creation of explicit foreign keys in the database.
Okay.
You have an operational investment table and a strategic goal table. The roadmap functionality demands a direct relational mapping between them.
Meaning, if a project manager tries to secure funding for an initiative, the system literally requires them to map it to an existing strategic goal ID. Like a GPS, you can't just drive. You have to link your turns to a final destination.
Exactly. If there is no relational link, the query fails the strategic alignment test. It shifts the burden of proof entirely. Decision makers don't have to just guess if a project is valuable. They can run a direct query to see exactly which high-level objective that project's primary key is mapped to.
It hard-codes strategic alignment right into the daily operational workflow.
Right. It proves if the proposed work actually matters to the enterprise.
To keep those queries running efficiently across the enterprise, the system has to ruthlessly manage its own digital clutter. Question 9. Notice the specific instruction here to choose to. Which specific criteria must be satisfied for the system background process to successfully clear out unsaved customized user views? Choose 2.
The correct answer is AC. The cleanup process targets dynamically generated views that were never formally saved and have remained unused for the configured retention period. Saved views or actively used views are generally retained because they represent intentional user configurations.
This sounds a lot like a garbage collection algorithm. But why does an unsaved view pose such a problem for the system? Why does it need to clean them out?
Because customized user views aren't just cosmetic, they often require the system to cache incredibly complex query logic.
Oh, I see.
Yeah, when a user filters, sorts, and groups massive data sets dynamically, the system allocates real memory to hold that specific view state. If users generate dozens of these complex views and simply abandon them, it completely fragments the cache.
It's like leaving hundreds of unused browser tabs open, just draining the computer's memory.
Exactly like that.
So the system is designed to prioritize intentionality over digital hoarding. It looks for the unsaved status, which means the user didn't flag it for persistence, and then it checks the timestamp.
Correct. The criteria represented by A and C must both evaluate to true. It must lack the saved persistence flag. A and D, its last access timestamp, must exceed the predetermined retention limit. Once both conditions are met, the automated housekeeping sweeps it from the cache.
That frees up database resources without ever destroying the views that users intentionally rely on.
Right. It reduces database clutter while respecting user configurations.
Okay, so we are clearing out the old cache to make room for massive external data drops, which brings us to our final architectural requirement today. Question 10. Again, note the instruction to choose 2. When configuring the system to allow bulk data ingestion via files containing comma-separated values, what structural requirements must the import template strictly adhere to? Choose 2.
The correct answer is BD. The CSV columns must correspond to the internal attribute identifiers expected by the target object so the system can map imported values correctly. The target object must also be enabled for importing through the appropriate administrative configuration.
Let's use a physical mailroom analogy for this to really break it down. You are dropping thousands of envelopes into the system. The first requirement, B, means the envelopes must be addressed perfectly. The CSV headers can't just be conversational names. They have to exactly match the internal database schema names, or the sorting machine just rejects them entirely.
That is an excellent mechanistic analogy. The system will not interpret intent. If the internal schema expects an attribute named pred, and your CSV header says project ID, the mapping fails entirely.
Yeah, it's a two-way street.
But requirement D is equally critical. Even if every envelope is addressed flawlessly, the mailroom will reject the delivery if the target department's mail slot is literally locked.
Meaning the specific target object in the database has to be explicitly authorized by an administrator to receive an external CSV payload.
Yes. By default, enterprise objects are secured against bulk insertion to prevent data corruption. An administrator must actively evaluate the object, authorize the import capability, and unlock that endpoint.
So the door has to be unlocked.
Exactly. You have to satisfy both constraints: the strict data sanitization of the headers matching, and the explicit security authorization of the target object accepting imports.
We've just walked sequentially through 10 essential questions for the Broadcom 250-609 exam, covering everything from blueprint configurations and financial entities all the way to roadmap alignments and CSV data ingestion requirements.